Okay, so let's work on some examples, all right? Got a parallelogram here. They tell me that, all right? If they didn't tell me that, or if they didn't give me markings, I wouldn't be able to prove it. So I don't want to just assume, all right? That's kind of the catch with geometry is you don't want to assume things. You want to go based on facts, based on evidence. Okay, so what do we know about as soon as I see this, I start thinking about what do I know about a parallelogram? Oh, the opposite sides are parallel. Opposite angles are congruent, things like that, or I just kind of think, if they look the same, they are the same. I can see that this is an obtuse angle, so is that, so I know that this is also 100 degrees, all right? That's obtuse and this is acute, all right? That means they're not the same, but I would be able to know that they're equal to 180, so if that's 100 degrees, then this is going to be 80 degrees. Now, that's not what I'm trying to look for here. I just wanted to give you some information of how to think about using parallelograms and their properties. In this case, we're trying to find the measure of angle L. Well, opposite angles are congruent. So therefore, if angle N is 100 degrees, then angle L is 100 degrees. The next thing was to solve for X. Okay, well, this is a side measure, not an angle. Angles are on the inside, side measures on the outside. So I've got this side and I've got this side. I know that these lines are parallel to each other, but what other information do we know about parallelograms? They are congruent to each other. Opposite sides are congruent to each other. They're the same measure as each other. So this measurement is equal to that measurement. All right, so I said KL is congruent to NM, therefore they are equal to each other. So I set the expressions equal to each other, and I just solve for X. Now that's all I had to do, but if I actually had to find the side measurement, I would take that value and I would plug it in for X and I would get my side measurement. All right, example 2. Okay, got a parallelogram. We're trying to find the measure. That's what that little M in front of this means. This is an angle symbol, right? Not less than, greater than. It's an angle symbol. And this M in front of it means measure. Find the measure of angle D. So I'm trying to figure out that angle measure. I would know it if I had something for its opposite because they are the same measure. I could also say, well, it's not the same as this one, so it's supplementary. I could just subtract from 180, but I don't have an angle measure here. The catch with this problem is that I'm going to have to use this information to first solve for X and then plug it in to find that angle measure so that I can find angle D. So that's what I did here. I said angle C and angle A, they're opposites, or they're both acute, they're the same, so I can set them equal to each other. And I did that here. I solved for X, and I got a value of 11. Now I wanted to find the measure of angle C, so I plugged it back into that expression, and I found out that angle C is a measure of 72 degrees. Now, angle C is not the same type of angle as D. This one is acute, that one is obtuse, so they're supplementary. That's why I subtracted the 72 from the 180, and I got a measure of 108 degrees.